Hi, I'm Raghu and welcome back to another session in the series of programming a Raspberry Pi Pico using Python. Functions in Python. Python allows its programmers to break up a program into segments commonly known as functions. Each function should be written independent of the others. Every function in the program is supposed to perform a well-defined task. In Python, a function is defined using the keyword def, followed by the name of the function. Why do we need functions? First of all, it allows reusability of code. As a programmer, when you're using functions from external modules, you can simply call these functions without worrying about how they work. Let's take the simplest example. In most of the programs, we use the print function. We don't need to worry about how the print function actually displays the content on the screen. We just call the function print. Without functions, we would have to implement the logic every time we want to display some content on the screen. And without functions, there'll be a large number of lines in every program. Each function has to be written and tested independently. So when you are writing functions, you're handing over a set of reusable instructions to other developers, or maybe yourself, which you can use confidently. Different programmers can work on the same project by defining the project into modules and functions. Each one can work independently on different functions. Attributes of a function. A function can be called by any part of a Python script or from another function. The function or script calling the function is called as a caller. A caller can pass additional information to the function if the function has defined arguments or parameters. For example, you could have a function that adds two numbers. The function would have two parameters to accept these two numbers. Def add, n1, n2. And in the function block, you would say sum equals n1 plus n2. You may either use the term argument or parameter for the information passed to a function. A function can return a value back to the caller. This will usually be the result of the actions carried out by the function. For example, in the add function, the sum of the two numbers has to be returned. A function does this by using the return keyword. The full syntax for the add function would then be def add, n1, n2, sum equals n1 plus n2, and return sum. Python has different types of function parameters. You can choose different strategies to accept arguments and call these arguments. One does not accept any parameter at all. This is quite straightforward. A caller has to invoke such functions without passing any parameter. The syntax is just diff function name, open and close brackets, and then of course you'd have the function block. Accepts one or more mandatory parameters. Such functions accept one or more parameters, and the caller must pass values for all these parameters. So in this case, you would have a diff function name, and after the open brackets, you would have a list of parameters like param1, param2, and so on. When passing parameters for such functions, the caller must be careful to pass all parameters in the correct order. The third type of parameter passing is by using variable length argument. In some situations, it is not known in advance as to how many arguments will be passed to a function. In such cases, Python allows programmers to make function calls with any number of arguments. When we use such variable arguments, then the function definition uses a star sign before the parameter name. The syntax for a function using variable arguments can be given as shown here. When calling this function, the caller can give 0 or more parameters after the name parameter. Default parameters. The next type of parameters is default parameters. Python allows programmers to define functions by assigning default values to the parameters. Such functions can be called by either passing values to these parameters or skipping these parameters. If a caller skips these parameters, then the default values will be used. The next is the keyword parameters. All along, while defining parameters for functions, we gave names to the parameters. For example, def add open brackets n1, comma n2. Imagine that the function has 10 parameters. Then when you call these functions, you'll need to remember the order of all the parameters and pass them in the correct order. This can become very confusing. To address this, Python allows you to call functions by using the names of these parameters. Example is as shown in this image. As you can see here, I don't have to pass the name as the first parameter. As long as I can remember the keyword name, I can use it anywhere in the function call. Lambda functions. Lambda functions are also called as anonymous functions. Lambda functions are not defined using the def keyword. Rather, they're created using the lambda keyword. Lambda functions are throwaway functions. That is, they're just needed where they've been created and can be used where a function is required. Lambda functions contain only a single line. It can have any number of parameters but can have only one line of expression. The result of the expression line becomes the return value for the function. Syntax of the lambda function is as shown in this figure. Lambda functions are usually used when you want to have the features of a function but don't want to go ahead and create the function. They are like throwaway functions. So now that we've talked about functions, I would like to give a small note about global and local variables. When you declare a variable in a function, that variable can only be used within that function. The variable scope is local to that function. Similarly, if you declare a variable in the main script outside the function, then you cannot change the variable inside the function directly. If you want to change the value inside the function, you'll have to declare the variable scope as global. You do that by using the global keyword. Hope you enjoyed this session and have got a good understanding of the concepts that we learned here. So let's move on to the next session in this series of programming a Raspberry Pi Pico using Python. So see you soon.